Hello folks, in this video I'm going to cover word embeddings, which is one of the method of representing words in numeric form. In the previous video I have already covered the other two methods like one-hot encoding and in fact one-hot encoding is a separate video, and in the previous video I have already covered TF-IDF to represent words into numeric form. And this is by far the best considered method when it comes to represent words into numeric form, because this method considers the context in which these words are used, because word embedding algorithm is so much powerful that it understands the relationship between different words in a sentence or a document. So please watch this video till the end so that you can understand this very important topic, as it's heavily used in machine learning and deep learning when it comes to processing text. Folks, this is Nitin welcoming you to the AI University channel, where you can learn all your favorite digital technologies like machine learning, deep learning, AI, big data, Hadoop, virtual reality, and cloud computing. And you can acquire these related skills in order to advance your career in these fields. This channel takes on hands-on approach to build AI-based products and applications. So if you are new to this channel, consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about the hottest technologies of 21st century. So word embeddings allows you to encode words in such a way that their semantic relationship and meaning with the other words are captured. Word embeddings are generally generated using a machine learning model, which can be typically an unsupervised learning model, which basically looks at the patterns of the words it has fed in the past. It is generally trained on the large corpus of text data. So once the machine learning model is fed into this large corpus, then it becomes ready to accept new words, thereby spitting out word embeddings for those words. Okay, so it will accept a word, let's say, or such as pizza, okay, and will then generate a numeric embedding for it. So this numeric embedding also captures the meaning of the word pizza. By feeding the large corpus of data to the machine learning algorithm, the algorithm actually able to understand that pizza is some kind of a food. So if you feed in words like burger, sandwich, which are some also some kind of food items, the encodings the encodings this ML based algorithm will generate for these food items will be very close to the encodings of the word pizza. So if you visualize these numeric encoding in some kind of a graphical representation in n-dimensional space, then you will find that encodings for these food items are very close together. Okay, and I will try to create a separate video for that, wherein I will be showing you how can we represent, or how these word embeddings are represented in a n-dimensional space. So I will be writing some code, so please stay tuned. If you want to visualize these numeric encoding in some kind of graphical representation in n-dimensional space, then you will find that encodings for these food items are very close together. That is, encodings for similar words like bus, train, aeroplane, car, which are means of transport. Okay, so the encoding for these will be close together as well, because these are means of transport, right? Now, you might be thinking, how does it do it? Well, data plays a very important role here, because you need to have a large corpus of data which contain many examples of words which are similar and used in different contexts. Machine learning algorithms are able to find these patterns of words which are similar to each other. Okay, the word pizza we feed in is called as the input word, and the output or a resulting numerical representation of pizza is called as the word embedding or word encoding. Okay, now one important feature of the word embedding that is generated in this manner is that it has very low dimensionality, and this low dimensionality embedding serves as a very compact representation of a word itself. The semantic relationship that this word has with other words and the word's meaning. Okay. Now, in order to get the good word embedding from the machine learning model, it's a very important that it trains on very large data set. So the corpus of data that you feed into this model is typically like all the topics and articles on Wikipedia or in thousands of books. So to say the machine learning model should have many examples of how the word is used in different contexts in order to establish the semantic relationship and the meaning of the word correctly. These words embeddings are amazing in a way that it captures the meaning, and because these word representations are actually numbers, you can compute things with words which you didn't think were possible. So if you do king plus women minus man, then it will give you the embedding as queen. There are two most popular algorithms which are used to generate these word embeddings. The first one, or the first algorithm, is word to vec. Word to vec. There are two implementations of word2vec. Number one is continuous backward words, and the other one is skipgram. Okay, so word2vec uses an input word to predict the words that surrounds it, or uses the surrounding word to predict the input word, which is a vice versa of the previous one. So this is actually fed into a simple or shallow neural network which allows it to learn word embeddings. Another word embedding model is GLOVE, or global vectors for word representation. This model doesn't use neural network. Instead, it uses word-to-word co-occurrence matrix and nearest neighbor algorithm to extrapolate word relationships. Okay. Co-occurrence matrix can be thought of as a window over the words in the text which allows us to determine which words tend to occur together. Okay, so folks, this is it for this video. To conclude, I explained about word embeddings in detail, also explained about two of its implementations. So let me ask you a question from today's video. We know that neural networks work with numbers. How can we represent this text data into some numeric form? Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also ask your technical questions in the comment section. I will be glad to answer your questions. If you're watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. And in case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.